Well, there's two theorems in this section with unique formulas, and they are for a sphere. So I've got myself a sphere over here with a radius r, and we've got a surface area, 4 pi r squared, and we've got a volume, 4/3 pi r cubed. Now it should be obvious that, well, the squared is always going to be with area, and cubes are going to be with volumes. So let's just get some exercise, get some practice with this. But you got to remember these, jot them down. So let's do some straightforward surface area calculations on samples 3, 4, and 5. We'll just go right to the substitutions. A radius of 4 feet, 7.5 centimeters. This one, diameter. Remember to chop that one in half. Perform the squaring. Remember, that's 4 squared, then times 4. 7.5 squared, then times 4. So now all your answers are in terms of pi. If you want the decimals, multiply by pi, and there you have it. Now let's move on to something far more exciting. Well, let's take the formula for the surface area of a sphere and work it backwards to solve for the radius. I'm given 32 pi for the surface area, and we all know what we're doing. We're dividing both sides of the equation by 4 pi, because of course the 4 pi's divide out here, the pi's divide out here, and 4 and 32, well, let me see, I know that 4 goes into 32 8 times, so this side of the equation is going to be simplified to 8. The right side is r squared, so it looks like we've got this, r squared is 8. Now, you could do this, taking the square root, you all know that, but you could also just go right for the calculator here. Oops, let's put in the 8, take the square root, and there you go, 2 83/100. That looks like it would be choice B. So that would be your solution. Well, here we go with a sphere centered at the origin, and we have a plane that's also passing through the origin. That means the plane intersects, or the center of the sphere. If I look at it this way, that plane cutting that sphere, it's going to cut right through the middle. So it cuts through a radius or a diameter. And when I look at it straight down, I can see that that intersection is going to form a circle. And that's going to be a great circle. It's a great circle because that circle contains the center of the sphere. Well, now that we've seen the 3D model, let's work off the book's drawing right here. Oh, favorite joke, why was 6 scared of 7? Because 7, 8, 9. Oh, I've been dying to say that. All right, let's find the radius, diameter, and surface area of one hemisphere for this figure. Now, circumference 2 pi r, and we're given that the circumference is 96 pi inches. Straightforward substitution. Dividing both sides of the equation, let's first divide out the pi. Let's stop there for a minute. Well, that's 2r. Well, that is the diameter. So we've answered number 8. And let's go a little bit farther. And of course we double it. I'm sorry, half, divide both by 2. That answers number 7. That is the radius. So we've got 7. Let's work on 9. Now, this merits discussion. I want the curved surface. I'm not including the solid or the circle that's generated at the intersection. That makes a difference. I'm not actually cutting this sphere in half. So I'm going to say it's 2 pi r squared, which is half of 4 pi r squared. Again, I'm not cutting. If I cut the solid in half, I'd have to count the circle on the exposed surface. So now let's just plug and chug. We've got 4.8. We square that, and we take that multiplied by pi to the nearest tenth. And remember, those are square inches. Oh, these error analysis problems are great. We've got a hemisphere here. You can see 5 foot, and a young lady standing there. And what is wrong with this picture? It's pretty obvious. We've got a hemisphere here. We have the curved surface, and then we have the area of a circle down there. So if I want to describe what's wrong, that would be the surface area. 2 pi r squared is for half of the sphere, and the 1 pi r squared is for that disk, that tan colored disk on the bottom. So there you go. That would fix it up. In this exercise, we're given the great circle of this sphere. That is the circumference of this great circle. You can see it right there on the red-green plane. And that is a circle that on the sphere, which would pass through the center of the sphere. So if we know that circumference of that disk there, let's find the surface area of the entire sphere. Well, that's easy enough. We're going to go backwards and forwards. We know the circumference. It's given as 48.4 pi centimeters. Again, a really easy time here because this has the units of pi. And just to exaggerate that point, we're going to demonstrate here we're dividing both sides, not just by 2, but we're dividing out those pi's. Very convenient to have it done this way for us. So I know now that my radius of the sphere, 24 2/10 centimeters. Well, that's backwards. Now let's go forwards. Our surface area, 4 pi r squared. Substitution. And let's do the squaring there. We still have to multiply by the pi and to the nearest hundredths. There you go. So backwards and forwards. All right, it's geography time. Here's the Earth we all live on, and we were going to calculate the surface area of the Western Hemisphere. Well, we're looking at the Western Hemisphere, and here's the boundary of it, in case we haven't talked about this in class. The prime meridian, as you can see right here, is one boundary. To the west of that, and to the east of this, the anti-meridian. If I looked at it from the poles, you can see cutting the globe in half here. Moving this way, I can see cutting the globe in half. So, in other words, we're going to calculate the surface of the Earth and take half of it. 1/2 the surface of the Earth. Let's get to it. All right, now we're going to find this area of the Western Hemisphere, which will be half the area of a sphere. And in order to do that, we need to start with the circumference, work backwards to find the radius. We'll do that in blue, do this in green. Oh, we're color-coded. So it's simple substitution. Well, we're giving 5 significant figures on this figure that's not really a perfect sphere, but let's go with this. Dividing both sides of the equation by 2 pi. This is what we're thinking. We're dividing everything by 2 pi. If you want to see the calculator, let's do that. We'll pull up that calculator and we'll take 24,855 divided by pi divided by 2. So that's going to be my radius. If I was obeying my sig figs, I could put that down there. 5 significant figures. And now I'm just going to leave it in the register. We'll execute this phase. We're going to square it, then multiply by 2, multiplied by pi. Where'd that calculator go? Right there. So let's square it times 2 times pi equals, hey, chihuahua, look at those numbers. 9, 8, 3, write those all down. When we perform this calculation, writing out the whole numbers, we would get this, and I just cut it off at the whole numbers. We're just talking about, but let's be fair, we only started with 5 significant figures. That would be 5 significant figures, but honestly, I generally see the Earth represented normally to about 3. That one, from our calculation, probably makes more sense to me. Any of those answers I would accept, but certainly I don't want to see any decimals, not with that many digits. All right, so there you go. We've explored our Western Hemisphere.